Here you're provided with three equations that go towards creating the target equation, and you apply Hess's law of additive enthalpies in order to determine the enthalpy of the target equation. Here you can see that I'm identifying in the target equation the chemical species that are present in each of the different series of equations. Once I do that, I can determine which items will cancel. So here we have 2 moles of water as a reactant and 2 moles of water as a product, so they cancel. There we have 2 moles of diatomic oxygen, and that cancels against the 2 moles of diatomic oxygen in the products. Finally, there's carbon dioxide in the reactants and the products, 1 mole each, they cancel. And then it's a matter of determining how to sum all of the enthalpies of the target equation. What's tricky is they've thrown a 2 in here, which means they are indicating that it is not necessarily a molar enthalpy because you need to reduce it by 2 to technically make it a molar enthalpy. And so if I reduce that value on the right-hand side by dividing by 2, using my son's calculator that he just purchased for grade 6 math, you get 285.8. I'm going to have to figure out how to change that from a fraction to a decimal.
Yeah, just to win.
The sign stays the same, and in the third equation, they're giving you a negative sign, so that means technically it's a negative value on that side of the equation.
Like the blood isn't at the surface, Dad. It's just like under the skin. You can just see it.
Once you convert all of the values so that all of the symbols are positive and by a factor of 1, you can sum all of these to determine the overall enthalpy of reaction for the target equation, which is 1569.6 negative. And I don't have the answer key on hand, so you'll have to tell me whether or not I did it right. But what I do think of is, gee, when I do this, does it make sense to me that 2 things added together would give off energy, free up energy? And we know that methane is in the atmosphere and it might be more stable that way, and so possibly it is okay that that's a negative value.